Okay, here we have the graphs of basic motion. So we're going to use a car as an example, and we're going to show what it looks like in the position, velocity, acceleration, and net force graphs. And we're going to use three examples: constant velocity, positive acceleration, and negative acceleration. So an object that has constant velocity is going to have, it doesn't mean that it's not moving, it doesn't mean that it has no forces. It means the forces are balanced. And so if I have a force of my motor this direction, I will have the force of friction in the opposite direction, and they will be in equal amounts, and they will cancel each other out, and it will look like this on our graphs. So what this means is that our forces that are on this, the net force is 0. That is as a result of some sort of a positive force and some sort of a negative force. And so the result is the net force here. And so the net force is 0. That means that your acceleration is proportional to your net force. And so your acceleration, I hit the wrong button, your acceleration is also going to be 0. So your acceleration is, wrong button again, your acceleration is proportional to your net force. And if your net force is 0, then your acceleration will also be 0. So that does not mean that you're not moving. It just means that you have a constant velocity. So whatever your velocity is that you start off with, if you start off with that velocity, you are going to stay the same velocity the whole way across. So your slope is 0, your velocity is not 0. So in this case we would say that your velocity is not equal to 0, but there is no change in velocity. So in our position time graph, that ends up looking like this. We start here, and we're going at a constant rate, so that's not changing. So finally, we do. We have a change in position. So look at the next one. In this next case, we're going to have a positive acceleration. So whatever our friction is this direction, our acceleration has to be greater in that direction. So our force of our motor has to be greater. So if our force of our motor is up here, then our friction must be here, which means that it's not going to equal to 0. So if I use red again for the force, for the net force, the net force won't be 0 right here. The net force will be somewhere in the middle, exactly in the middle actually. It will be the positive minus the negative. So this will be your net force, and your net force is greater than 0. It's positive. And so your acceleration will also be greater than 0. So your acceleration is proportional to your net force. And that means, yes, we are accelerating. So if we start off with a 0 velocity, our velocity will change just like this. And that will mean that we start off slowly, so we're going to begin to curve upward like that as we go faster and faster. So now we do have a change in velocity, yes, and our change in position is a curve because we are accelerating. Anytime you're accelerating, we have a curve. So the last case scenario is now we're going to slow down. So in our slowing down scenario, we have our force of friction, and we're going to add to it our braking force, so the force of the braking. So that's going to put us, really quite negative. And so our forces here are going to be negative, which means our acceleration also will be negative. I guess I'll go back to red on that to show that. Acceleration will also be negative. And if our acceleration equals negative, then we are going to slow down. So if our velocity starts off here, then we are going to slow down to 0. And what that looks like on this graph is that means we were going some speed, and then we started to slow down, and then now we are stopped. And a straight line means we are stopped. So that's what we have.